attendees. Good morning, attendees. So I'm Hiroki Nabae, Assistant Professor at Tokyo Institute of Technology. Today I have a lecture about the devices for pneumatic control and examples of application. So first, I start with the general introduce the general knowledge about the devices for pneumatic control system, and then I would like to introduce the applications of those pneumatic control systems from my research achievements. So first, I briefly introduce myself. I'm Hiroki Nabae, and my specialty is in actuators, robotics, and mechatronics, especially in the novel actuators. And I received the bachelor, master, and PhD degrees from the University of Tokyo. And from 2015, I joined Tokyo Institute of Technology as an assistant professor. So now I'm a member of Professor Suzumori and Professor Endo's lab. And sorry, so in this slide, Professor Endo's is associated professor, but now he is a full professor. And yeah, in our research group, we study about the new robotics systems from the basic components from the field test applications. So this is a plan of timetable of today's lecture. So first, I introduce the devices for pneumatic driving systems, and after Q&A, we have a 10 minutes break. And after the break, I introduce examples of applications using pneumatic driving systems. Okay, so start with the general knowledge about the devices for pneumatic driving systems. So this slide shows the general robotic or mechatronic system. So generally, robotic system driven with the electromagnetic actuator is shown here. So it's a general one, but this photo shows the linear driving system, and this area shows the microcontroller and softwares. So general robotic and mechatronic system sense obtains the environmental information by the sensors, and the sensor values are obtained via AD or DIO or counters, and the microcontroller can calculate the how to drive the actuator from the informations, and the command value is generated. The command value is sent to the motor driver. So sorry for Japanese. The motor driver can send the energy or energy input to the actuators, and then the robot can operate it. So when considering the pneumatic driving system, so instead of the electric energy, The pneumatic driving system uses pneumatic energy. It means compressed air. This slide shows the general pneumatic driving system. So pneumatic driving system generally consists of compressors which generates the compressed air. So it behaves as an energy source. And the regulator regulates the pressure to the robotic system. So often compressors and regulators include the tanks or filters. And controller or computer, it means microcomputer or PC, generates command values which decide how to operate the robot. The command is sent to the valve. Often it needs a driving circuit, but the valve controls compressed air energy from the compressors or regulators according to the command values from microcontroller. And the controlled compressed air is sent to actuator, and the actuator can move. It generates the motion of robots. And often robots have the sensors, and the sensors obtain the information of environment, and the information is sent to the controller, and the controller can calculate how to actuate or how to move the robot. So first you design the robot, I think, and so you design the robot like what kind of motion robot do, or what kind or how much force or torque the robot can generate. And after the conceptual design, you should calculate or decide the required pressure. It often related to how large robot can deform or move, or how much flow rate is required for robot. It related to the motion speed of the robot, and how much degrees of freedom is required for the designed robot. It related to the number of valves, and what kind of control or what goal is required for the robot. So just switching the on or off of pressure, or the pressure control is required. So you should decide by calculating the requirement of those values. After that, you should decide what kind of product is required for the pneumatic driving system for your robot. So first, I start with the compressors. So compressor is, I'm not sure you should decide the compressors or the project have already prepared the compressors, but the critical parameters for the compressor is flow rate or pressure range. So when you design the robot or after design the robot, you may decide the flow rate or pressure range for your robot. And based on those values, you can decide the compressors. So these are typical compressors for pneumatic driving system. So these are not only the compressors, it includes the tanks, but many compressors has already includes the tanks to how can I say so, to stabilize the pressure output. And next is regulators. The regulators regulate the pressure from the pressure source. So often the pressure generated by the compressors is higher than the operating pressure for the robot. So generally speaking, a regulator decreases the pressure from the pressure source like the compressors to stabilize the pressure output or or generate the optimal pressure for the robots. So these two regulators are typical regulators. So this is the regulators with the analog gauge, and this regulator includes a filter for cooling the air from the compressors here, and this regulator has a digital indicator. So when you decide the regulators, you should the critical parameter is the pressure range. So when you design the robot, you decide the pressure range for operating the robot. So you should select the regulator suitable for your robot operating range. And the one of the most important components is the bulbs. So there's many kind of bulbs, but the solenoid bulb is I think the most popular bulbs for controlling the pneumatics. And the upper side figure shows the pneumatic solenoid bulbs with 3-port, and the bottom 2 figures shows the pneumatic bulb with 5-port. The compressor or regulator is connected to the P-port here, and actuator is connected to port A here, and R port is connected to the environmental air, to release the air pressure. So when you switch on this bulb, the pressure port or P port and A port is connected, So the actuator, the compressed air is applied to the actuator, and actuator operated. Actuator is operated. And when you switch off this valve, the A port and the R port is connected. So the actuator is connected to the air. Then the air pressure is released. So the actuator returns to the initial state. So for the simple actuation of pneumatic soft actuators, this three-port valve is often used. And then I introduce the five-port pneumatic valve. So when you switch on this five-port pneumatic valve, the pressure port is connected to A port. And this, the P port is connected to the compressors. And EA port and EB port is connected to the air. And A port and B port is connected to the actuator. And when you switch on this valve, the P port and A port is connected. It means that so A port is pressurized. And B port is connected to the EB port. It means that the B port is released to the air. And when you switch off this valve, the A port is connected to EA. It means that the A port is depressurized. And the B port is connected to P port, and the B port is pressurized. So these are typical solenoid valve operation. And then I explain the relationship between the actuator and these valves. So this slide shows the three-port valve, and this is a simple figure represents the simple pneumatic actuator. When this room is pressurized, this rod moves here, and when this room is depressurized, this rod goes to this direction. So this kind of actuator that has one loop, the three-port valves is enough. So when the valve switch on the valve, the P port and A port is connected. It means that the compressed air is applied to the actuator, and the actuator operates like this. And when you switch off the valve, so actuator is connected to the air, and the actuator depressurized. And then the actuator return to initial state like this. The next is when you use the five-port valve. Five-port valve is used for this kind of actuator. So this actuator can move to this direction by applying the pressure to this room. And when the pressure is applied to here, this actuator can move the opposite side from this situation. So when you switch on the valve, the P port is connected to the A port here, and here is pressurized and move to the right side. And when you switch off the valve, the P port is connected to the B port, and here is pressurized and go to the left side. So the 5-port valve is used for this kind of actuators. So we return to these figures. So far, I explained the compressor and the regulator and the valve. So the rest is how to operate the valve. So valve can operate or switch the compressed air from compressors and controls the airflow to the actuators. And the valve should be controlled by controller. But generally, solenoid valves needs a large electric power for operation. But the controller like microcontrollers or PC cannot output high electric power. So we need some driving circuit for operate the solenoid valves. And when you select the valves or controllers, you should take care about the voltage range and the required power. So microcontrollers often, most microcontrollers can output the voltage, so up to 3.3 voltage or 5 volt. And the operating voltage range of the valve is 12 volt or 24 volt, or so you can choose. So to control the valve with microcontrollers, you should build the electric circuit for driving using some transistors. Using transistor is the popular way for those kind of operation. This figure shows the typical electric circuit for the driving. So this figure shows the driving circuit using bipolar transistors. So this photo is typical, shows the typical appearance of transistor. So this port is from the microcontroller or PC. I guess you may use the microcontroller. And here is a voltage source which can output the enough electric energy for driving the pneumatic valve. So this electrical circuit is often used for driving the electric motors using a microcontroller. So these two elements represent resistors. And this here shows the transistor. So transistor has three port, and one is emitter, and one is collector, and one is the base. The transistor can when the current, so important thing is that the small current is applied to here base. Transistor, the large current can run from the voltage source to this here. So it means that the large current can control with small current. It also means that the large electric power can be controlled by small electric power like microcontrollers. And this figure is shows a typical electric circuit using FET. FET is one of the transistors. But so in this bipolar transistor can generate the electric current according to the current applied to the base. But regarding FET, the current is based on the voltage applied to this gate port. And when you apply the voltage here, the large current can run from the voltage source to the ground here. And how to build this electric circuit? How to decide the resistors are very important, but in this class, so we don't have enough time to introduce how to decide the resistors. So please check the website or manuals of the product which you use. And the important point is that so each transistor has a limitation for the current and voltage. So you should select the transistor or FET according to the voltage or electric power which is required for the bulb. So this slide shows example for how to select the resistors for the bipolar transistor electric circuit. So V-in means input voltage by the microcontrollers. And so IC means electric current from the voltage source bear the load. In this case, the solenoid valve. So the transistor can allow the current to run here according to the current value, IB. IB means current run to the base here. And the relationship between IB and IC is expressed as this. And this value is described in the manual of the product. So this is the current gain of the transistors. And when you decide the bulb, you can decide the required current here. And you can calculate, you can decide the input voltage when you decide what microcontroller you will use. And the register here is calculated by this equation. It's decided by the microcontrollers, and VBE is decided by the transistor. And IB is calculated by this equation with the parameters of the gain and the current for the bulbs. So you can decide these registers. So far I explained about the solenoid bulb, but when you use the solenoid bulb, you can only control the two states. The maximum pressure is applied, or the pressure is equal to the air. If you want to control the pressure precisely or continuously, if you would like to control the pressure with continuous value, you can use the electron pneumatic regulator. The regulators I introduced previous slides, those regulators, how can I say, so regarding to those regulators, we should adjust the pressures with our hands. But electron pneumatic regulator can control the pressure with electric signals. So it's very convenient, but it costs a lot. These photos shows typical electron pneumatic regulators. So when you select the bulbs or these pneumatic regulators, you should take care about the flow rate and the pressure range for operates your robot. And to control those bulbs, you should take care about input voltage and electric power source. So it means that how much electric power is required for those devices. And this slide shows other components for pneumatic driving systems. So this photos shows hoses and connectors for construct the pneumatic systems. So far I introduced some components or devices for pneumatic controls, but you should connect each devices. So when you connect those devices, you need the hoses and connectors. And it is very important for how to select these components. So there's many types of hoses and connectors. And you should take care about the diameters and the logistic pressures. So the valves or compressors or regulators need the specific diameter of connectors or hoses. And those diameters are often different. So you can adjust the hoses with connectors. So some connectors can connect the different diameters of hoses. You should prepare those connectors if the valves or regulators or robots needs the different diameters. And the pressure range is also important for the safety. And this component is manual valve or manually controls pressures. So when you automatically operate the robot, it doesn't need, but when you test the robot, it's very convenient for conducting the test. And this speed controller is also very important. So when you use the solenoid valves, you often notice that the motion of the actuator or robot is too fast. And many students are considering that they have to control the pneumatic pressure with pneumatic pressure continuously. So because if they gradually decrease the pressures, the actuators can, the motion speed of actuator or robot can be decreased. But there is more simple way to decrease the motion speed of a robot. So speed controller can regulate the flow rate. So, and the flow rate strongly affects on the motion speed of actuators. So only you put this component into the pneumatic systems, the generally put just before the actuators. You can decrease the motion speed of the actuator or the robot. It's a very simple way to control the motion speed. So maybe it's important to select the components with manuals or specifications of each devices according to the performance or required values for the robot you designed. And please take care about the pressure range and flow rate. It means the response type. It's very important to select the pneumatic components. And when you decide the pneumatic components, you should often you have to prepare the electronic or devices for controlling the valve or electro-pneumatic regulators. And when you choose or develop the electric circuits, please take care about input voltage or input power. So input power means the input current. It is very important to so if you take care about those parameters, you can develop the robotic systems using the pneumatic pressures. The first part is over. So is there any questions?
Any questions from the students? Let's check the message. Okay.
Okay, so okay, how about 10 minutes break?
Yes. So right now, Taiwan time is 10:43. We can come back at 10:53.
Okay.
So 11:43 in Japan.